Morning folks, 3 days to go. Let's go. So, starting off with the Foundation Plus, we have a simultaneous equation to open up, but this is quite a nice simultaneous equation because it's got plus 3y and plus 3y. Same sign, so subtract, and we have the same numbers, so we don't need to multiply to start with either. That'll give us 3x is 21, x is 7, and then we could substitute that into either of these equations, but I substituted it into the top one to get 35 plus 3y is 41, so 3y is 6, so y is 2. You could also have substituted it into the bottom one and got 14 plus 3y is 20, 3y is 6, and so y is 2. Either way, same answer. Second question is a difference of two squares. So we've got here y squared minus 144, and difference of two squares in general is if you have x squared take away b squared, that always factorizes to a plus b, a minus b. So in this case our a is y squared, so we'll square root that to get y, and our b squared is 144, so we'll square root that to get 12. If you've got nothing in the middle, it's just the plus minus the same number. Next question is kind of a trial and error approach. So you could, I think, be fooled into thinking, well, I'll set these two equal to each other and solve it. But it doesn't say that it happens at the same point in the sequence, and all n tells you is like the point within the sequence. It doesn't tell you the value. So the best way of doing this question is to write out the two sequences in question. We've got 6n minus 4, so we could do 6 times 1 minus 4 is 2, 6 times 2 minus 4 is 8, 6 times 3 minus 4 is 14. Or we could think, well, 6n means it's going up by 6 each time. So just add 6, add 6, add 6. And you get these sort of numbers. If we do the same with 10n plus 2, it starts with a 12, and then it's going up in 10, so it's 22, 32, 42. It's all the numbers that end in 2. So if you want a number that's in both sequences, you need a number in the first sequence that ends in a 2. 32 is one option. If you kept going, you would also get to 62 or 92. Those are all possibilities. Volume of a pyramid, this is the formula we should know. A third times base area times height. The base is a square, so 4 squared is the base area. Third times 4 squared times 6 gives you 32. Units are centimetres cubed. Next one is a compound interest question. So a depreciation, that means a decrease of 20%. That means the multiplier that goes with this is 0.8. You're taking it away from 100% to get to 80%, and then switch it to a decimal is 0.8. The formula that you need to know is this original amount times multiplier to the power of years. So the original amount was 20 grand, the multiplier is 0.8 as we've just said, and then the number of years is 3. Do that all together, 10,240. It's also possible to do that by taking away 20% to get to 16 grand, then taking away 20% of that, but you know, that takes longer. It's good to know the formula. Okay, on to higher. So this starts off with a fiddly-ish equation solver, and I think the easiest thing to do is to take away the 5 to start with. Just subtract that from the 6 on the other side, say equals 1. It might be tempting to multiply by the x minus 3 straight away, but if you did that, you'd have to make sure you multiplied the 5 by it and the 6 by it. You've got to multiply each of those 3 separate terms. So I think it's easier to just reduce the number of terms and take away the 5 to start with. So we did that. And we've got 5x plus 2 over x minus 3 is 1, and then we can go through Mechford to make x the subject, essentially. So multiply across by the x minus 3, expand that bracket, collect the terms by taking away an x and taking away a 2 to get 4x is minus 5. No factorising needed, then divide to get x is minus 1.25. Happy days. Factorising, we've got the same thing again. We've got the difference of two squares, except this time it's 9y squared. So we need to square root the 9 as well as the y. And we need to square root the w squared as well as the 49. Square root of 9 is 3, square root of 49 is 7, so we've got 3y plus 7w and 3y minus 7w. That's our answer. Next one is a sector. Now a sector is a slice of a circle, and it says it's got side length of 4, so that's actually the radius of the circle, because that's like the length of the straight bit, which helps. So I think drawing this diagram is kind of crucial. It says the area is 10, so we want to find the angle. So we need the formula that involves the area, and that's this one here, x over 360 times pi r squared. Arc length will be x over 360 times pi d. So we'll sub in the things that we know. We know the area is 10, we know that radius is 4, And so we can rearrange this to get x the subject again. Times across by the 360, divide across by the 16 pi, and you've got x is 71.6 degrees. Next one is not a bad indices question. We've got a fraction, so the bottom number is the root, the top number is the power. 4th root of 16 is 2, 2 cubed is 8. Job done. Move on. And we've got a simplifying to go. Now, if it is algebra, or it's a bracket to a bracket, you want to multiply the powers together. So don't forget that y is the same as y to the power of 1. So we're going 1 times 3 for the power of y, and we're going 4 times 3 for the power of x. But we also need to go 2 cubed, because numbers, you just cube them. Onwards to higher plus. This was fiddly, and I think obviously the words prove that mean quite a lot. So what doesn't work is trying some numbers and showing that this works for 1 or 2 or 3. A proof means that you can show it always works, that you can put in whatever algebra you like and it will always work. So we need to expand and simplify, essentially. So we work out what m plus 1 squared is. We work out what m plus 3 squared is. And then we add those two things together. So I've got here my expanded m plus 1 squared, my expanded m plus 3 squared. That gives me overall 2n squared, 8n, and 10. And then it said to take away m plus 5 squared, so I work out what m plus 5 squared is. And I subtract that from what I've got, so 2n squared, take away n squared, 8n, take away 10n, and so on. And that gives me n squared minus 2n minus 15. And then I want to show this is equivalent to m plus 3, n minus 5. So I expand m plus 3, n minus 5, and show that you get exactly the same number, so it's the same. That's the algebraic way of doing a proof. Next one's a bit simpler. So a circle's got this equation. This is the formula that you should know. For a circle, x squared plus y squared is r squared. So this is our r squared, so we square root it and get the radius is 1/3. Remember, you can square root a fraction, if you didn't have a calculator, by square rooting the top and bottom separately. Then we've got this, which is a quadratic inequality, and there's a couple of steps involved here. The first step is we need to basically solve the quadratic. So you basically ignore the fact that it's got this less than equal to 0 sign, so less than 0 sign, and you just try and solve it as is. And I'm using MAM here because if it's 6x squared, there's loads of possible factorizings. It could be 3x and 2x, or 2x and 3x, or 1x and 6x. And I want to avoid having to check them all. So we're using MAM. MAM says we need to multiply to these two, so 6 times 7 is 42. And we need to add to this one, so that's minus 13. So multiply, add, multiply. This gives me the numbers minus 6 and minus 7 because they multiply to 42 and they add to minus 13. And what we do with that is we split the center up. We split 13 into 6 and 7, or minus 13 into minus 6 and minus 7. We then factorize each half. We combine our brackets together, so 6x minus 7 comes from there, and x minus 1 is just the bracket we've got. And then we solve. So flip the sign, divide by how many x you've got. We end up with x is 7/6, or x equals 1. Another option is you could have used the quadratic formula, of course. So that's step 1, solve it. Step 2, sketch it. So this is a positive quadratic. I know that because it's 6x squared, it's not minus 6x squared. So its general shape is a U shape. I know it goes through the x-axis at 1 and 7/6 because that's what we just worked out. Or you could think about this as being like x equals 1. I think it's like 1/7 or something. So I mark them on the x-axis and I have a U shape that goes through them. So that's a quadratic sketch. Y-axis it goes through at 7 for what it's worth, but you don't need that. And then step 3 is we want to know when this is below the x-axis. Now we want to know when it's below because the question says less than 0. If it said greater than 0, we'd want to know when it is above. So it's below the axis here, and between those 2 points that we just came up with. So we'd write down as our final answer that x is between 1 and 7/6. So yeah, quadratic inequality, you've got to go through all 3 of them steps to get full marks. It's very much a end of paper question. But I think you could all do the first part. And then the last question wasn't too bad. Looked difficult, but wasn't actually too bad in the end. So there are two formulas that you basically need to come here knowing. The first one is that volume of a prism is its cross-sectional area times its length. The other thing you need to know is a trapezium area, which is a plus b over 2 times height. And if you know those two, which are in theory grade 5 skills, you can answer this question. So what do we have? We have a swimming pool full of water, it empties at a constant rate, goes down 5 centimeters in 20 minutes, how long does it take? So what we need to know is we need to know the volume of the pool. That's the first thing we need to know. If we want to know the volume of the pool, because it's a prism, we need to know its cross-sectional area, and we need to know its length. Its length is 12 meters, that's fair enough. Its cross-sectional area, which is this bit here, that's a trapezium. You might need to turn your head to the left to see it, but you've got your A as 1 meter, you've got your B as 2.4, and you've got your H as 25. So we'll plug that into the formula that we mentioned up here, A plus B over 2 times H, and we'll get that the area of the trapezium is 42.5 meters squared. We can then use that to get the volume of the pool, because it's a prism, is that times the length, so 510. And then I thought about doing this quite a complicated way to start with, because it says it goes down 5 centimeters in the first 20 minutes, so I thought, well, maybe I'll draw the shape 5 centimeters lower, and I'll find out how much that is, and then I'll find the difference between that and what I started with. But it's way easier to find out the volume that's left the tank. So I drew the bit of shape that had left if the water goes down 5 centimeters, which all it is a very, very thin cuboid on the top. We're not involved in this slopey bit at all, so all the awkward stuff about trapeziums and triangles and stuff goes away. So the volume that's left is a cuboid, which is 12 by 25 by 5 centimeters, but we wouldn't write different units, so we have that as 0.05 meters. We can multiply those three things together to get the volume as 15 that's left, and then we just need to find how many times 15 fits into the 510 that we know the whole volume is. So 510 over 15 is 34. So each of those 34 represents 20 minutes. 34 times 20, 680 minutes, or 11 hours 20. That's how long it'll take. Cool. Some interesting questions there on Higher Plus, particularly the quadratic inequality is a toughie. Hope that helped. See you tomorrow. Cheers.